Hello, my friends. Let's talk about infrastructure as code, specifically Terraform. So this is a companion lab to another one that I did on cloud formation. I seem to like Terraform a little bit more. Maybe it's just because when you learn cloud formation, it seems a little bit more complicated if you go through the console and you learn to use the GUI that they have there for their infrastructure composer. And this is just all text uh, and code editors, and you do it from your local computer. And I don't know, that makes it seem a little bit simpler, I suppose. At any rate, let's go ahead and dive in. Just as before, when you're talking about infrastructure as code, it's really important to be able to build up your environments using code rather than doing it manually because things get out of hand when you are talking about thousands of applications that you might be supporting in a large organization, and all of them could have multiple environments, including testing, staging, and production. So you want to build up your infrastructure using code to keep it consistent and also to keep it secure. So you can, even if you have hundreds of versions of your application running, if they all launch from one set of infrastructure as code, you know exactly what the firewall rules are, etc., and you can change them all in one place if you ever need to update things rather than manually going into lots of different places. So there's a lot of advantages to using infrastructure as code with modern DevOps. Um, so let's go ahead and dive into Terraform. So just maybe some background. I actually haven't looked into the other cloud providers other than AWS, but I assume all of them have some type of infrastructure as code tooling, similar to CloudFormation, which AWS has. But CloudFormation is specific to AWS, and so there's an what was an open source one called Terraform from HashiCorp, and that one was created to be cross-platform. So in their language, they call a particular hyperscaler a provider. So AWS, Azure, Google Cloud Compute, um, those are all providers in their language, and you can just learn one language, the HCL, the HashiCorp configuration language, and that will apply and in any of the cloud environments. You can even launch into multiple ones simultaneously with your infrastructure and your applications um, if you have your document coded up the right way. All right, so here's kind of, I think I took this from their material. Here's their development process. Um, at a high level, you select who would like which. So if you're going to start a project from scratch, like how do you do this? Well, first off, which scaler are you going to be working with? Is it Azure? Is it Google, etc.? What is it that you're intending to do? So think about, I need virtual machines, I need a certain number of IP addresses, I need certain firewall rules. So we will call that the requirements. Then you write up those requirements using the syntax, the code language that we have for Terraform. You run the code, and then from time to time, your requirements will change. You'll need to, for example, add instances, um, change the firewall rules, etc. So that means you're going back to items 2 through 4. So you'll update your requirements conceptually, and then you will update it in the document, and then you will run it, and it will update your environment. So that's that. And then we can go a little bit more granular for how we do the coding process within Terraform, which is you install Terraform first of all. You create a project, you create a file that you can run, and then you do Terraform apply. So you just run one command line command against your development working file. In this case, it's going to be main.tf as we go further in here. And so, anyway, that's just a high level. Or so we have all these diagrams and stuff, but the high level idea is you write some code, you say apply, and it runs and it creates something in your code environment. But you can go a little bit deeper, and you'll see some examples of additional options. Okay, so the first thing you need to do is go out to the HashiCorp website and download Terraform, and you can follow the instructions for installing either on Windows or on your Mac. And I think for me, I think there was just like some homebrew command that I ran that was found on their website, and then it's installed, and then you'll know if it's working if you can do the following. Terraform. So in any command line environment you have on your computers, whether it's PowerShell or um, just the terminal on a Mac, if you type in Terraform and it spits out a bunch of stuff, then you're in good shape. That means it's running and it is working. So we're good to go. Okay. Now, one of the things that we're going to put in the top of all of our documents is now we're going to be creating our documents locally on our local computers, and they're going to reach out to the cloud to do whatever it is that we want out there. And in order to do that, we have to have credentials that act as you, as if you were logged into the console. So basically, you need administration type usernames and passwords. And in the AWS environment, we'll call that the access key and the secret key. Anyway, it's just a pair of like strings that together are work the same as a username and password for doing stuff in your account. So if you've done something like this example you see right here, which indicates I want to work with AWS, I want to work in this region, and here's my username and password for an administrator. If you put that at the top of your document, then you can go ahead and write other syntax after that that will do all kinds of stuff in your environment. All right, so I'm going to move this off to the side of the screen and so that I can do what it says in my AWS environment. So we're going to go into um, the IAM, Identity and Access Management area. And what we need to do is create a user, and I'm going to go users, and oop, I have one right there, and I'm just going to go ahead and delete it because I can, and then I'll start over again. Okay, off it goes. So we hit refresh, create user, and user name will be Terraform user, and we go on to the next one, and we're going to be giving it in this case the ability to do stuff related to EC2 only. So I'm going to attach a policy and I'll say EC2 full access. So this is the policy or the set of permissions that will be applied to this user. So they can't do other things like update my billing or see my bills or anything like that. Work with, I guess, S3 or it can just work with like VPCs and EC2. All right, so I go next and I will click create user, and I don't know, why does it say entity not found? That's weird. Hmm, okay. Anyway, back to users again. I don't know why it did that. That's some weird stuff. Okay. I don't know what it is I was just seeing there, but this is what we're supposed to see. You see your list of users, and there's one of your users. Okay, so one of the challenges we have here is that we don't have any username and password set up for this. So I'm going to click Terraform user. I'm going to go under security credentials, and to create those strings that I was showing you before, we go down here and we click create access key, and we're going to scroll down to where it says we're going to be using these keys with a third-party service. Are you sure that you want to do that? Yes, I do. So go ahead and hit next. And maybe I'll just write in a description of this Terraform EC2 user. That's why I'm creating it, in case I ever wanted to know why it exists in my account. And I click create. Aha, and now I have this username and password. I'm going to download this so I can click the show, or I can download it because I'm going to need it. So I'm going to go to in my to delete folder, and I'll go ahead and just, I guess, put this in here. I had it before, and I will open it up. And I will delete this after I do this video, so you can't do stuff in my account. But there's my two parts of my access key information. All right, so let's go ahead and check our little tutorial here. So we've created our user, we've downloaded our key. Let's go ahead and learn how Terraform works now through a couple of examples. So the first one is we need to create a project. So I'm going to, well, I've already got a folder here on my computer. I maintain a to delete folder. So I will call, let's see, make a new folder, uh, file. Sorry, it's a little hard with all this stuff on the screen. File, new folder. I know you can't see it, and I'll call this uh, example one Terraform. Okay. So all I did was create a folder called example one Terraform. And I'm going to open up VS Code and then open up that folder. Now, technically, all you need to be able to run Terraform is just some text that you've written out and then the ability to write commands at a terminal. Um, but I found that you can do both of those at once in VS Code, so I will do that. So I'm going to say uh, open, and I will find my to delete folder somewhere over here, and there we go. All right, I don't need that. So this is the folder that I'm going to be working in. And the first thing I'm going to do is create a file called main.tf, and it's smart and it gives me the icon for Terraform. And the first thing we do is, oops, first thing we're going to do is we're going to copy and paste in this code. So let me go ahead and put that in here. Now we're going to need to replace this. I'm also going to need to think about which region I want to work in. For now, I'll go ahead and do US East 1. And then another thing I need is that file I had a minute ago. So I'm going to grab this key, and that was a key ID, and this is the secret key. All right, so this code would theoretically allow me to connect. What, go ahead and following my tutorial. What's the next thing I need to do? I want to add in something called a resource, which is going to create basically an EC2 instance using a particular virtual machine profile and a certain instance size, and I can give it a tag. So let's go ahead and grab that, put it in there. Some things to note, it's basically got syntax that reminds you of JSON. And let's go ahead and get started now. Okay, so I hit save and I'm going to open up the terminal in here. If you were doing something separately, like writing in a text editor, you could, uh, and that didn't have an integrated terminal, you could just use this to browse to the right folder and then type in the same commands. So if I type in present working directory, I can see where I'm at. But the first command that I'm going to type is terraform init, and let's watch what happens. And it's taking a second here. And notice that it created a hidden folder here and some other things. All right, the next thing we need to do is check and see if this is valid syntax. So in order to check to see if we have a valid file before trying to run it, we can type Terraform validate, and by default, it's going to look for main.tf. And I do that, and let's see what it says. Well, it's taking a long time. It says success. You have written a syntactically accurate document. We think that it will probably work. So the next thing that we can try is typing Terraform plan. And Terraform plan is going to show us what this document is going to create in our AWS environment before we actually run it. So if I scroll up, it's says it's going to the fall app server will be created, and these are things that it knows it's going to do. Um, anyway, so quite a bit of stuff. Although technically it's really just one resource, but these are settings related to the resource. Okay. All right. So now we can actually create this thing. Terraform apply. And it's going to ask us, do we really want to do this? And you have to type in YES. And it can take, 35 seconds for it to complete this. So let's see what we're expecting as time goes on. We say yes, 35 seconds or so will go by, and then it will show us the ID of the EC2 instance that's going to be created on our account, and we can go in and we can verify that it is there with the correct tag and all that good stuff. So here we are. This one says it created an instance that ends in 2C2. So let's go ahead and check our account. So I look in here. I have one running instance. Oops, let's see. Oh, I'm in Ohio there. Let's change to North Virginia. There we go. And it ends in 2C2 and it has a tag. So everything worked correctly. Yay! And so if you're doing this assignment for me in my class, you're supposed to write down what your EC2 instance ID is. Um, all right, let's do some other things. So another option you have is after you've been running things, you can type in Terraform show. So this is a little bit less useful since we just did something, but let's just say that it had been a minute since you'd been working on this project, and by typing Terraform show, we can see resources that have been created up in the cloud as part of this project. So these largely this is showing for this particular EC2 instance what are different attributes of it, including things like the hard drive that it's using, etc. So there's a lot that goes into running an instance, and we didn't have to manually specify all these things, but they do exist when it's running. All right, so one of the nice things about infrastructure as code is even though um, there might be a lot of stuff. We only created one resource, but you can create a lot of resources. And a nice thing about running infrastructure as code is if you create a lot of things, you can create them all in one command, Terraform apply, but you can also get rid of them in one command, which is going to be Terraform destroy. Do you want to do this? Yes. And it can take up to a minute for it to actually destroy this. So while it's destroying it, let's just talk about what we're going to do next. So the next thing we're going to do is move beyond the example of creating just an EC2 instance, um, because we can use our configuration code to create a full-on VPC with subnets and security groups. And so I am going to use this as basically my instruction or my recipe for what I'm supposed to do. So this is effectively my requirements. And then we're going to turn these requirements into HCL, into our configuration language. So let's look at some of the key features here. We've decided to use Ohio, so US East 2. We have a named VPC with this specific CIDR range. We have an availability zone, which is US East 2A that we are specifying. We have a subnet, which is a subset of this overall range. We have a security group with certain firewall rules, and we have an instance created in it. And so I think we will only limit ourselves to one security group in one instance, so I'll stop short of doing both of those. We also are going to need an internet gateway. So the thing that makes this example more complicated than the last one is usually you need like, six, seven, eight different networking components in order to build out your VPC. And when you do it in the console, uh, in terms of requirements, these are the only things you think about. But when you do infrastructure as code, it adds in the additional complexity that in addition to having like a VPC and an internet gateway, they'll have things like an attachment, which is considered a separate resource. So to have these two things you and then have them connected, you need three entries in there or three resources. So you'll see what I mean as we go along. But first, let's check what happened from the code that we ran previously. And it says one thing was destroyed after about 30 seconds. And let's see if I click up a couple times. Terraform show. Is there anything? Nope. All the stuff that we had is now gone. If I come here and I click refresh, there's nothing there. Now I'm going to be working in the Ohio region. And I think this was what I was practicing yesterday, so I better get rid of this so that I don't mess up the the example that we're about to go through. All right, so not that you need to do the same, but um, this will be gone in just a second. It says it's shutting down. Um, so you just should not have necessarily a web server that says Donut Web Server. Okay, so that'll be gone in a second. Let's go back to our code. So I go back to my code editor, and I'm going to be creating a new project as part of the next instruction. So I'll call it Donut Website Terraform. All right, so let's go ahead and I'll go into here. And within this project, just to keep things organized, I'll just put a new folder in here and I'll say Donut Website Terraform. So this will be my project. And I will go, let's see. Um, okay, annoyingly, my screen is, let's see, open folder. I Okay, hold on. I'm gonna pull this into the other window here, so because I can't see any of my tools when I have the screen recording going. It's like I'm gonna say File, Open Folder, and Example, Donut Website, Terraform, Open. Okay, so now it opened the right folder. Sorry, I had to change windows there for a second. And so there's nothing in here in my project. I don't want to see the welcome window, but I am going to need main.tf. So I'm going to create another main.tf file and note that we need to create our provider information again. And this time I'm going to be using region US East 2. So let's go ahead and put that there. And I need to find my credentials. There's my credentials once again. Then I'm gonna grab my access key, put that there, and we're ready to get started. Save. Okay, so the first thing we need to do is create our VPC. And unfortunately, um, there's always a starting point for everything, and the starting point is learning how to use documentation. So if we search the web for AWS Terraform documentation, we'll see a link that says latest docs from Terraform. So let's go ahead and go there in a second. And while we're in there, we can go down the list of things on the side and look for something. Well, okay. On the home page, we don't have to actually look for something specific yet because the home page tells us about the like how do you connect to the AWS as a provider. And it also gives you an example of how to work with a VPC. All right, let's go ahead and pull that up really quick so that we see what I was talking about. So I could do AWS Terraform documentation. And sometimes I get ads and stuff at the top for other things. But today it just came up with this link that I was looking for. And on the home page for this, it does show over here on the side all kinds of services that you may be familiar with, like EC2, and probably S3 is going to be in there somewhere, I assume. Um, and there's going to be a VPC in there. But on the home page where it just says provider, if I scroll down in this main window, it gives an example of how to select a provider, how to select a region, and how to create a VPC. So I don't need to go necessarily any deeper initially to learn how to create a VPC because it's right here. But later on, we'll look for it within the documentation itself. Um, so let's go ahead and I'm going to copy this information and I'm going to, well, hmm. Okay, what I tell you to do in the instructions, here, let me just copy and paste all this. What I tell you to do in the instructions is copy all of that and put it into here. Um, Interesting syntax. So notice that before I had written things this way in our previous example, um, and this one actually has a Terraform resource that you can create, which is a little different. So at any rate, it's fine. All right. I'm actually going to steal some of the stuff that I have right here. So I'll say copy and paste that. And I'm going to cover up the US East one and put in the credentials. And then I can get rid of that. Because again, it's just a copy of the provider block. So all I've done is copied from their website and I updated that information, which will provide um, our connection. Okay, so now I'm going to open up a terminal and start working on this. So I'm going to initialize my project by typing Terraform init. And by the way, this one is going to create a VPC once we get to the right place. So I'm going to do Terraform init, Terraform validate. Do I have good code up here? Waiting, waiting. Okay, and then I'll do, and it was a yes. So Terraform apply, and I'll say yes. Now this probably won't happen to you, but I make enough stuff in here that sometimes I get error messages because I've run into the soft limits of how many VPCs you're allowed to have in your account. So anyway, that's one of the errors I get from time to time, and then I have to go in and basically make room for more VPCs by deleting one of my old ones. Okay, it says a VPC was created that ends in 4F9. So I make sure I'm in the Ohio region and I look for VPCs. Here's a list of my VPCs, and I have something that ends in 4F9. Okay, so yay, it worked, and there's the right range. All right. So if you're doing this as part of my class, you're supposed to write down your VPC ID. Uh, And so the next question I ask is like, okay, that was nice that VPC was right there on this homepage for the documentation for AWS, but what if the thing you were trying to do wasn't there? Well, you would scroll all the way down to VPC, Virtual Private Cloud, and there it would be. Um, and within there, there's going to be one called AWS VPC. And here is our code. And we can look at some examples of things like this is the basic way to create it. And um, here's something with a tag added in. All right. Now, one of the things I wanted, well, so let's go ahead and build on this because according to my diagram in the instructions, we want to have our VPC called VPC production. So let us go back to our thing here. And this we're going to now change to VPC production. And we're going to add in a section here from the example in the documentation of equals name equals name equals production. Okay, and just for fun, let me just look at this again. Okay, it is what it is. All right, just for fun, I'm going to introduce a little bit of an error, and I'm going to put 24 here. Now, if you recall, 24 is supposed to be the size of my subnet and not my VPC, but by making this too small, it introduces something that I need to change later on. So we'll pretend like I made an error. But the key thing right now is we've given this thing the proper name, and we're giving it a tag for when it shows up in the EC2 console or the VPC console, either one. All right, so we'll type in, I'm going to click up a couple times on my arrow, and I'll say validate. Is this good syntax? And let's go ahead and say, ooh, let's actually look at plan. What's it going to do? And it's saying it's going to get rid of the VPC because I changed its size. And when you change the size of it, that's something that requires the old one to be destroyed. Anyway, so it says it's going to get rid of one and it's going to create another one with these parameters. So now I can do Terraform apply and off it goes. It's off to the races. Oops, I forgot to type in yes. All right, so let's come over here and I'm going to hit refresh and I see stuff. I see stuffy stuff. Um, and I think I forgot to replace this one from yesterday when I was practicing. So actually gonna delete this one and say goodbye, everything. Okay. So this with the slash 24 is what is going to this is what was just created, I believe. Let's come down here and we can confirm it ends in 5DC and there it say 5DC. All right, let's look at what we need to do next. So it's there. And one of the things we need to do is add an internet gateway. So we're gonna go through the documentation and we're going to copy and paste this example. And let's see. And then I'll talk about some of its parameters there. So first thing is I'm going to go to AWS Internet Gateway. There it is. And there's an example of the code that I would need to use. So I'll come over here and at the end of my document, I will add that in. Okay, so let's comment on this a little bit. So this part identifies the type of resource that we're going to create, and notice it matches the name over here in the documentation. This is basically the variable name or logical name that we're going to give to this resource when it's created. When we create an internet gateway, in this case, we're planning to associate it with another resource. Well, we named this resource a variable name VPC production. This one says create a VPC and reference the ID, or sorry, associated with a VPC. Um, and it says AWS VPC.main.id. So it wants to know the ID of the VPC that was created up here. Here's the type of resource it is, but then has the word main. Well, you probably don't remember, but the default in the documentation says that the resource is called main, but our resource, we gave it the variable name VPC production. So to refer to that one up above, we're gonna give it the appropriate name and then reference its ID. All right, and then we want to give this a name, and we're going to call it um, Production Gateway. So why not? And we're going to give it a name and call it Production Gateway. All right, so with that, we should be able to save it. Let's go ahead and validate it. Let's go ahead and click on plan. It says it's planning to add one thing. So we come up and it says when it runs the next time, it's going to leave the other stuff in place, but it's going to add this new production gateway in US East 2 and give it a tag, and we're good to go. And it's going to associate it with this particular VPC. Interesting that we referenced that VPC using its variable name .id, and it translated it for us and put it in there. All right, so let's go ahead and apply that. Type in yes, and let's go ahead and check our account. So I'm in my VPC, I check internet gateways, and I have something here that says production gateway, and the 5DC I think is the one that that we were just working with. Yep. Okay, so it did successfully create an internet gateway for us. Yay! Okay. Um, let's go ahead and look at what we need to do next. So, oh, actually, let's go ahead and introduce a problem. So, if I had left it, let's see, if I had left it at its default, which was main, and if I had done the validate, that would be something it picks up. It just says, hey, I don't know what main is in the context of this document. It doesn't exist. So I'm going to undo that change. And let's go ahead and look at what our next step is. So next thing is we should build a public subnet. So a subnet has documentation under AWS subnet. There's example code for what that's supposed to be. And as I look at that, it says we're going to need to reference as part of the documentation the right, we need to place our subnet. Well, we need to give it a name and we need to place it in the right or associate it with the right VPC, and we need to give it a good CIDR block. Um, and this is the part where I'm supposed to go, oh yeah, I messed up on my implementation of my diagram. This is supposed to be 16 and this is supposed to be 24, because if this is 24, then I'm not able to make this a smaller subset of it. So by having my error introduced, I can change two things at once. One is I'm going to add in a block for my subnet, and I'll just copy and paste this. So I would have gotten that from the documentation and then updated it a little bit. I updated it here, 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 and here. Let's go ahead and put that in there. And then because this is 24, let's go ahead up here and do 16. Okay, so technically because we made this type of change, you can't just modify this on the fly, so it's going to destroy my whole VPC and reassociate an internet gateway with the new VPC. So all kinds of great magic's going to happen, and it's going to create a subnet that's a part of that VPC. Um, all right, did I miss anything? I think, well, one thing that occurs to me is I could specify which availability zone I want this to be in, and I did not. Um, oh. All right, let's just go ahead and try and run this. And it's gonna create an error on purpose, but I say validate, and it says, yeah, it works. So let's go ahead and just go ahead and apply it. And we say yes. And so what I did conceptually is straightforward. I changed my VPC, which has an internet gateway attached to it, and I added in a subnet. Now, you would think, oh, it should be able to do this. And had this been cloud formation, it probably would have done this correctly. Um, the nice thing about Terraform is it tends to execute a lot faster than cloud formation, but it executes faster because it uses APIs and it just tries to do like granular commands oftentimes, and it doesn't oftentimes see the whole picture of what's going on in your account. And so sometimes it gets stuck and it doesn't realize that there's a dependency that needs to change in order for it to do the change that it wants to do. So in this case, it's hanging, hanging, hanging. It's just not going to work. It's saying I can't. What it's specifically doing is it's trying to delete this VPC. We can see the ID and it won't let it. Well, if it won't let it, let's go ahead and hit Control C and that will stop. And let's try and do it in the console and see why it's failing. So I go to the VPC and I find this thing and I say, go ahead and delete this, and it says I'm going to delete this, but it says I'm also going to delete that production gateway. So therein lies the problem, is it's trying to send an API call that says delete this, but it needs to technically delete this first in order to do that. And when I'm using the console, it's aware that I've got both things and it'll delete this and then it'll delete that. But when I'm using the API through Terraform, it tries to delete this and it just fails because this is still connected. So every once in a while you get so there's a saying that like Terraform's great at creating things, it's not as good as deleting things. Okay, so I got rid of that. Let's go ahead and run this one more time. And now there's nothing up in there in the cloud, so it's going to create everything. It's going to create the VPC, the internet gateway, and the subnet. It hung, it broke, I deleted stuff. This time I added three resources. There's my subnet. Um, Actually, let's go check, see if it actually made it. So I come over here, I hit refresh. There's my VPC with a brand new ID, and it ends in 706. I've got a subnet called production subnet, and let's see. Is that the one I just created? Oh, there we go. So we got production subnet. I had to hit refresh. That happens sometimes. You pull up a page, you think the internet would be smart enough that you bring up a page and it doesn't show you stale data, but oftentimes in AWS, you view a page and you hit refresh, hits the back end, refreshes its cache of data for stuff that you're looking at. Anyway, so there's 706, the VPC that we are now using, and there's the subnet that just got created. Um, I don't think I cover this anywhere in the lab, but I was supposed to specify which availability zone this was going to go into, and this one put it into US East 2B. I'm sure I could have specified in the documentation AWS subnet. I'm sure I could specify the availability zone that it's supposed to go in, but I did not do that. Um, anyway, so it would be easy to do, and I could use AI if I wanted to get the right syntax and if I wasn't sure, but I don't want to slow myself down, so I'm just going to move on forward. Okay, this subnet is technically not a public subnet because to be a public subnet, it needs to be attached to a route table that has internet access. So let's go ahead and just kind of poke around here for a second. So here's my subnet, and my subnet is attached to this route table. And what this route table is showing me is that any traffic in the 10.0 range can be delivered to or within this subnet, but any traffic that is bound for the internet or from the internet has no pathway to get in. Usually, when you create a VPC, it creates a default route table that is limited and doesn't have outward connectivity to the internet. And so there's a few things that need to work together in order to have a public subnet. So first off, you need to have the declared public subnet. You need to have a internet gateway attached to your VPC, and then you need to have a route table. Now notice this is a property of my subnet. I need a route table associated with my subnet. You can have lots of route tables. We need to have a route table associated with my subnet that sees the internet gateway and sends traffic through it. So I actually need a couple of entries here and not just one. And I do a little preview in this screenshot of this is roughly what it might look like if it was set up correctly, in that you could local traffic for my subnet of a particular range of traffic gets delivered locally. But if it's not in that IP address range, it needs to go out to the internet via the internet gateway. And we don't have that right now. And so this is the code. So we won't, it's a little bit more lengthy to work with all the routing and stuff. So we'll just do a lot of copying and pasting here, and I'll just kind of describe it. So this one says copy and paste this code that has, it creates a route table, and then resources within the route table are routes. So here's two different routes. One route is for local delivery of traffic, and another route is for anything else. And it says for anything else, deliver it through the internet gateway. So I'm going to copy this block of code. I'll even take my comment there and put it here underneath. Hit save, and let's just see if it works. Cool. Okay, it has been created. However, I know that there's something we have not done. So, although it's created, it's not associated with our subnet. So, what do I mean by that? So, here's our subnet, and here's the route table associated with it. And it's the old one. If I go over here to route tables, I see this right here. So here's the route table I want to use with two entries. And then like one of these over here is the the route table that we're currently using if I just look up the right ID. So basically, we need to associate this with the right route table, and we could do it, manually here, but we don't want to do that. That's why we're using infrastructure as code. So, the way that we can do that is we add another route, or sorry, we add another resource. I was looking for another R word called route table association. And so this is it. There's documentation in the left column of our documentation page with this resource there. Um, and I've already edited it. And in here, I give it a name and I say, so I need to connect two things. I'm going to say, well, the subnet I'm going to use is this subnet. And the route table I'm going to use is this route table. And if I've named them right when I created them using that part, then this should work. So come back down to here, paste, save, apply. Yes. Okay, it said it added something. Let's check our account and see if everything was updated correctly. So I go to so here's my subnet. I hit refresh. Aha. So now I'm associated with the route table with this ID, and these are the attributes of that route table. So now I technically have created this right here, my public subnet that has access to the outside world through the internet gateway. Okay, the next thing we need to do is create a security group. And the security group rules are a little bit lengthy, so we'll be doing some copying and pasting again. Although I'm very familiar with security groups, there is a little bit of syntax that's a little bit harder to scrutinize. Like, okay, what do those words mean? They use some terminology in there that I don't always use. So I fiddled with it for a little while until I got the right syntax, and you get the benefit of copying and pasting what I have written. The high level thing you need to know is that these are the rules that you're trying to apply. Let in port 80, 443, and 22. All right. Now we don't have an EC2 instance to associate it with yet, but we'll create the firewall rule. So if we go to AWS Security Group, we would find this documentation. Let's just look at it for a second. It has things like, uh, so here's the security group, here's a name for it, and name. This is interesting. Okay, security group. So basically, they created a named security group and associated it with a VPC, but they didn't create any entries yet. And then once this is created, and they gave it this name, so it could be any name you want. It could be Donut Firewall, like whatever. But they called it Allow TLS. And then after they create the security group, then they start creating rules. So ingress means like incoming. So create an incoming rule and call it this, allow in port 43. Allow in outgoing rule, call it this, and this is the command for that. Here's another outgoing rule for um, IPv6. So, and then like IP protocol -1, all ports, like that's like something that I'm not used to seeing, but whatever. So for us, we are going to adapt that a little bit. We'll call it basically the donut firewall and we'll give it a description and without giving it any entries, there we go. So there's our firewall and associated it with the right VPC, but we haven't given it any actual rules yet. We've just simply named it. So we come on down and there's the incoming rule. We're going to allow in port 443. So I've edited that, associated it with the right firewall rule. Well, sorry, there's a firewall, and this is a firewall rule here. So we're associating this firewall rule with the right firewall. So I copy and paste the 443 incoming traffic rule, and we're in good shape. I'm going to go down a little bit, and now we're going to let in port 80. So it's basically the same rule, just with some syntax changes, and port 22 as if we were going to SSH into this. Okay. Um, I think so. One of the things I'll note here is that you can limit who's allowed to SSH into your thing. I said allow access from anywhere, but you could put like your own fixed. Like if you type in like find my IP, you could type in that address /32, and then only your computer on the in the world could access your firewall, or sorry, your instance with protected by this firewall rule using SSH. But I just opened it up for everything for now. All right, and then we need to open up outgoing traffic on this firewall rule. And again, this says just basically allow out all traffic. And with that, we'll save it. We made a lot of changes. Let's just go ahead and say apply. We won't necessarily validate or plan this. It just would have said we're going to add in a bunch of resources related to the firewall. All right, so it created this firewall stuff. And if we want, we can go to um, now, technically, we can look for firewall rules under VPC as well as EC2 in the console. So this menu of information shows up in both places. So I click on security groups, and this thing that says SG Donut Web, I believe, is the one that we just created. And if we look at the inbound rules, those are the expected inbound rules, and the outbound rule says it allows out all traffic. So there it is, and it's associated with the VPC that we recently created. So our infrastructure as code did its work. Thank you. Thank you very much, Mr. Roboto, if you're familiar with that song, for doing the jobs that nobody wants to. All right. All right. So if I repeated the four or five things that we had for the security group in case you just needed to copy and paste and replaced all of that information. Okay, so possibly the last thing we're going to do here is create the EC2 instance. So if we were to look under our documentation, notice that right now we're in the VPC portion of things. So if I look for AWS EC2, it's not specifically there. So I could go up to a different type of documentation and look for the resource called EC2. There we go. And if I look for like AWS, uh, which thing am I looking for? AWS instance. I was looking for EC2. Like, why can't I find it? So if I go to AWS instance under EC2, here I can see examples for how you create an EC2 instance. Now, we did that in our first example, and at least I think we did. No, I can't even remember now. It's been a while. At any rate, we can if we put in just like EC2 instance code into our environment, uh, into our code editor, it will by default create it in a particular in a default VPC. So as we create an EC2 instance, there's actually a lot of settings that we have to apply. So one of those being like, where do you want to put your EC2 instance? So this is like a very, whoops, let's go back to our example. Um, so let me scroll down a little bit and find some more examples. Or do we have any more examples? Well, I guess we don't. Okay, at any rate, um, with these things, you specify a lot of things. You can specify here's the reference. You can, okay, which region are we going to put it in? Which VPC am I going to put it in? We can specify how like what storage amount we're going to put on there, what's the size of our EC2 instance. So there's like a lot of things that we could technically use for this. Also, we needed to like specify which AMI ID are we using. which is related to like, do you want to use Ubuntu as your starting place for Linux? Do you want to use a Windows machine? There's a lot of different things you can pick in there. And one of the things that we need to do is select the AMI, meaning the pre-made image that we're going to work from. Again, is it Ubuntu? Is it Windows? Is it a different form of Linux? Is it, anyways, lots of different ones out there. Is it Red Hat? So, one of the things you can do is you can specify one of AWS's pre-made AMIs. And the way that you can find that is if you are in a particular region. Now, I made a mistake the other day. I was like, why is it that I'm doing my code for Terraform with EC2 instances that I'm spinning up from two different regions and it's breaking in one of them? Well, the reason why is, and let me just go to EC2 and say launch instance. When I go to launch an instance, the AMI ID that's listed here, this is what we need to specify that we're going to use one of these in code. It's different if I'm in one region versus another. So if I go over to North Virginia, they don't have this AMI ID there. So when I'm writing my code, I need to make sure I use um, an AMI that exists in the region that I'm planning to work in. And I've done that work already. So we should see, like, for example, a 31 as of today, and this can change all the time. I see a 31E here, and I've got 31E in my sample code. All right, so basically, I looked at the documentation, I figured out what I want to do. I want to use this AMI ID, and I want to do instance type t3.micro, and I want to give it a tag. So let's go ahead and, oh, this is fun. I left something out on here on purpose. Pause do. So this is going to work, but it's not going to work the way we want it to. So see if you can pause the video and think for a second of what's going to go funky for us. So I'm going to go Terraform apply, and we'll discover what it is. Do you want to add that? Yes. Spin up an instance. And let's see. So like I said, it's not going to break. It's going to work. It's going to create the instance, but there's going to be something contextually that it does that we weren't expecting. So creating, I don't know, it might take it 20, 30 seconds. Let's just go ahead and come over here to my account. I'm in Ohio and I've got a running server with the right tag. Okay, says it's initializing. I'm going to click on it and it's got a public IP address. I haven't installed a web server, so it's not going to do anything. But if I go over here to networking, notice that it put this EC2 instance in the default VPC for the region of Ohio. So that's the thing that stands out. And it's also not in the sub, and because of that, it's not in the subnet that's part of the VPC. So I created a VPC, I created a subnet, and I just put my EC2 instance not in what I created. And the reason for that is because I didn't specify where it was supposed to go as part of this code. So if we do a little bit more digging around, we can find the right information for that. I found examples on the documentation pages saying things like, oh, you can specify a subnet ID. Well, the subnet is tied to a VPC, so all we need to do is do the right subnet ID. So I'm going to copy and paste this all again. The only thing I really added was this. So let's go ahead and replace this. All right, and just for giggles, let's go ahead and do validate. There we go. And let's do plan. And let's see what it tells us it's going to do. So we screw uppity up, and it says the resource with this variable name, and we named it this variable name, it says it's going to be replaced. So it's going to create a new one with certain attributes and it's going to be anyway. And because of that, it's going to basically delete the EC2 instance. Anyway, one to add, one to destroy. There's some, if we don't want to look through the details, you can just look at the summary at the end. So it's going to add one resource to our account and destroy one resource. So we say apply, and it's off to the races. So if I come over to my account and I click refresh, let's see, we've got nothing interesting is happening yet. What I should see, uh, did I forgot? Yes, I forgot to hit yes. This has happened a lot of times in my life. All right, so I come back to here again. I hit refresh, and it says it's shutting down one of these. This is one that I did yesterday, but it's shutting down one of these. And after that gets shut down, it is going to create the other one. And there can be a lag on this, 45 seconds or whatever. Okay, so one is terminated. How long will it take to create the next one, create the next one? Okay, that was fast. Okay. All right. Um, and it doesn't say that it's okay, now it just says it's done. So it destroyed something, it added something as we were expecting. Sweet. We can also check if we want by looking around at well, we might as well. Um, let's just see that everything's right this time. So this time, as far as networking goes, come down to here, networking. We see it's in the VPC that we created and it's in the subnet that we intended. We go under security and we should see that it's protected by the security group. It's got the wrong security group there. So we did not specify that. Ooh, so that's something that can be fixed. All right, so another thing that we can find is if we look through the documentation, um, interestingly, the parameter here is VPC security group IDs. Security groups can be protected by more than one firewall rule, so they can be layered. And I actually didn't find the direct documentation for this. I'm not trying to brag here, but I didn't find the direct documentation. But I was like, well, but I read it and it said IDs. I'm like, well, that sounds like an array. So I just used syntax for an array and I put one thing in there and I put in a reference to the security group that I intended. So copy paste. Let's run this again and fix it. So there's my web server. Now it's cut that. And let's go ahead and hit apply. And the nice thing about it is that this type of change doesn't require us to like break anything. Notice the wording here. It says there's going to be a change to this EC2 instance that will be in place. And because it doesn't say replace, it says in place, that means I don't have to, I meaning the the cloud doesn't have to delete this resource and recreate it in order to apply this change. It's saying I can just take an existing thing and change things out. Now, why is this important? Because let's just say that we had gone in with SSH and we'd configured it, this instance, and we'd applied, we'd created basically a website. We had all kinds of good stuff in there and we just needed to change the firewall rule. Well, one of the reasons why we do Terraform plan is to see that it's going to be an in-place change. It's not going to wipe out our EC2 instance to make this change. And ahead of time, if it is going to wipe it out, we might need to maybe make a backup of our EC2 instance or something like that. So anyway, I didn't actually do the plan thing, but it would have told me it was going to be in place if I'd have done that. After the fact, it told me it was in place, and so that's nice. So if I were to come back to here again and hit refresh, it didn't show up. The change probably didn't show up. But if I refresh the whole page and make it like a brutal refresh, a very hard refresh, now I see that the changes that I wanted have taken place, and I'm with the correct named security group. I think we should be close to the end now. So that got our change. Oh, dang it. There's another change to make. Okay, so another thing that I can see that's broken is if I come to just details on the front page here, I don't have a public IP address for my EC2 instance. Well, there's syntax for that. So again, if you look through the argument reference, the attribute reference here, like associate public IP address, it's supposed to be Boolean. I wish they'd given me a syntax example. So I just made it a guess as to what that would be, and I got it right. And it's just put the word true in there. So one more time, copy, paste, and just curious, Terraform plan. Is this something that requires a replacement, an in-place replacement, or a total replacement? Oh, this one is going to destroy our EC2 instance. So it says it can't do this without recreating it. So however it is that they do things on the back end, that's what's going to happen. So it'll kill the EC2 instance, create a new one. It'll take 60 seconds for that to happen. And type in yes, it's on its way. So 60 seconds from now, it'll show up in the console correctly with this after I refresh the page. And I think we're about done. You are done, finally. Cool, cool. Anyway, even though it's a little bit lengthy for me to talk through doing this, I find this stuff to be very cool and very powerful. I do like it a lot. It gives me some type of endorphin rush to work with it. If I wanted to do some extra things, I could also associate a key with it. So let's just see what I mean. So if I wanted to be able to SSH into this thing when it is running, I would need to go down to key pairs and create a key, find a key that I want to use for accessing, from a terminal window, this EC2 instance. And so I could do that, and the syntax would be this. After I've got the key set up in there, say, here's my key name, there it is, run it again, and it would work. Um, all right. Again, learning syntax code in any infrastructure as code is a little bit challenging the first time through, but the nice thing is that oftentimes you only need to make like little incremental changes like we just did here, and it's super powerful because you don't just use this on like one EC2 instance or something like that. You can create some pretty sophisticated environments, and it allows you to basically manage your whole, if you will, your whole AWS account or your application in the account in one place. You can see what the security is. If you need to talk to a security person for an audit, you can say, hey, we don't even need to log right into our account. We can just look at this as the rule that I use to create the stuff, all my infrastructure, and they can say, oh, I see the 5 entries you have there. You are good, you're not good, whatever. So it's nice to be able to work with things that way. Another comment would be this is a tiny document that we have. If you had, oftentimes you would break things out into a bunch of documents, like one for networking, one for your EC2 instance, etc. And especially when these things start to get hundreds or thousands of lines long, it's nice to have separate documents with a separation of duties. Another thing you can do is, now we didn't do it in this example, but what you can do is pre-program the stuff that you would do at the command line and put it into something called user data. So for example, if normally when you start up an EC2 instance, if you wanted to turn it into a web server, if you usually do upgrade and then install Apache and then start Apache and then enable Apache to run when you restart the computer, and then you could even do like a little echo command here that would populate your Apache. Uh, you could even do some other commands here, but at any rate, anything you do at the command line when you're typing, installing software, it's grabbing something from another server, unzipping it, uh, pushing your code out to your server. All that stuff could be done in a set of commands here, which is super powerful because this means that every time you run this infrastructure as code, in this case, you can see it's grabbing the latest instance of an image, it's immediately patching it, and then it's installing software. And this is an alternative to creating a golden image, which is where you create your EC2 instance, SSH into it, get it running perfectly, and then you say create a snapshot of it. And the downside to go ahead and refresh this page. The downside to creating a snapshot is that let's just say that it was 6 months ago that you create a snapshot of something from which you launch future pages, is that it's got whatever security holes or whatever were available or exposed 6 months ago. And when you launch things this way, every time you launch it, it's all nicely patched with the latest version of the operating system. So just a different way of doing deployment. Um, and if you wanted to try all this stuff that I just talked about, like starting Apache and stuff, you could. All right, so let's remember to do Terraform destroy. So I'm going to come over here and do Terraform destroy. And away will go everything we created. The EC2 instance, the security group, the VPC, the internet gateway, the gateway attachment, the subnet, etc. So it all goes away in one batch, and it all could be created again in one batch. So just trust me that everything's going away. And with that, we will end this nice little tutorial. I hope you had a good time and that it helps you in your career. Take care.